between thermal anomalies and mineral analysis. Thank you very much for your attention.
Apologies again for the inconvenience. Now we go to the last presentation of this active process session, and it will be given by Julie King, identification and assessing mineralization processes using 2011 USGS data products. And Julie comes from USGS Denver, Colorado.
I'm going to use my 3 minutes to provide you with information on how to access recently completed USGS imaging spectroscopy data products for Afghanistan. The data were collected using the HIMAP sensor flown on a WB-57 aircraft. We covered 70% of the country of Afghanistan, approximately 438,000 square kilometers worth of data. The whole country maps were released about a month ago and were last week's featured presentation on the cover of EOS. It's a 2-series of maps showing the mineral distributions. The first one based on carbonates, phyllosilicate, sulfates, and the second one on the iron-bearing minerals. Based on these data, we've compiled thematic mineral maps for 21 areas of interest which had a high potential for mineralization. It was based on previously existing data. The thematic maps for the tin tourmaline area and the Zarkashan area are going to be featured in this next couple of slides. The footprint of all the vast majority of the 21 areas of interest we looked at that had a high potential for mineralization have been expanded, or the mineral associations have had a better understanding with the ore formation processes based on the results of the thematic maps. This is for the Zarkashan region. You can see the white outline is the intrusive body. There was a limited known coverage of the scarring materials on the intrusion edge, but based upon the HIMAP data, it's also been expanded greatly. And we have also identified areas that had not been previously been known to be mineralized. The summaries for these 21 areas can be found in this USGS Open File Report number 1204. Based upon the anomalies, or the areas that were not known to have previous areas of mineralization, more than 350 of those such areas have been found in the 21 areas of interest. This is an example from the tourmaline area, and you can find this summarized in this USGS Open File Report, which is 1229. Thank you for your interest.
Thank you, and thank you very much also to show that the hyperspectral can work on a regional basis and not on local basis. I think it is incredible work mapping Afghanistan with the hyperspectral sensors, and we should learn a lesson from that. Now, I see nobody here in the audience. Anyway, what we will do is we will ask the authors to come here and sit here in the front row. And there is a screen outside. There are some screens also within the exhibition hall, but I would prefer not to go there and spread around. I would suggest that we will continue here. If somebody has questions and somebody wants to meet the author and ask him questions, this is the place, and you can put his presentation on the screen here and outside and discuss the topic of his presentation interactively or whatever it can be. So I would ask the authors to come to the front row. And all right. So if somebody has any, I mean, this should be open conversation, open discussion, whatever. So if you feel that some of the presentations were interested and you would like to ask questions, that's the place. So I do it as following. Let's go to the first presentation. If somebody has questions, somebody wants to meet the author. I would like to have a question. You came up with the idea that you can measure lead by reflective spectroscopy. And what are the wavelengths that you are thinking for that purpose? Do you have maybe you can.
Actually, we can't find the range of spectral. We need to do or find detection for lake because the component of soil is different from sample to other sample. So in this case, we can't focus about range, limited range of spectrometer wavelength. So we need to try to find signature when we spike it late, and after that maybe we can get a good result.
Other questions about assessing lead contamination using reflective spectroscopy? Yes, please.
This kind of analysis by using high-logger spectrometer. So we spiked some lake from the soil. Then we got care for analysis. But unfortunately, in the initial result, the reflectance was very weak. So we need to improve this care by using some methodologies like PLS. Then we apply the same analysis to find the signature.
Any more questions?
Is there energy for that to be absorbed in a specific place?
No, we chose the place related with high concentration of clay. So we don't have idea for that.
Yeah, but you should have specifically have the idea of what place it's at.
Yeah, this is the initial signal. We don't have the but it's kind of analysis
more questions about liquid contamination? I think it's very interesting work, and we should proceed with that because the tracking spectroscopy gives us very, very powerful potential to map. Once you will have very good signal to noise ratio data taken from orbit, and this will be one of the application elements. Thank you. Thank you. So the author will be available for you to ask questions today and maybe even tomorrow. Next presentation was my presentation. If anybody has questions, it's the time to ask. Yes?
Can you expand on the optical device you described towards the finish, the optical pulse instrument?
Yes, this is a device we have developed in which you can use every spectrometer you have, and what you do is you take the fiber optic, put it inside, and there is 4 optic in one side, and in the other side, attached to it, a video camera. Because sometimes it is not enough only to get the soil attributes. If you would like to classify the soil, you have to know the structure. So this is why the video is there. And what you do is you dig a very small borehole and you put it like catheterization. So you put it 5 centimeter by 5 centimeter by 5 centimeter, maybe less even, and then you get the whole profile on in situ with all the soil attributes and structure of the profile. So you don't have to open any more trenches if you are soil surveyor or somebody that wants to describe the soil profile. So it's kind of a very neat thing because doing this borehole takes you a couple of minutes, doing the measurement also a couple of minutes, and it's actually not commercially, but it is available, and we can produce it one by one, and we sold it already for 2 customers. But this is very, very simple idea. Other questions about this presentation? Yes?
What you try to measure is soil texture, like grain size, or clay content and so on, or also other parameters?
We have, there are some or many works in the literature show that it is possible to estimate all those parameters that you mentioned, including particle size.
Yeah.
So what we do, we try to generate models for each of the soil attributes that are very important for soil classification. So it's clay content, carbonate content, iron oxide content, moisture content, organic matter, and sometimes also particle size. But if you search the literature, you will find many other soil attributes that can be detected or extracted by soil spectroscopy. There's a very, very nice review paper of Isprs Russell from CCIO. He was summarizing all papers, all attributes that have been done since 2006. I'm sure that there are many others since then. But I think it's stable technology today to say that soil spectroscopy is a very good tool to estimate and even proxy soil attributes solely from spectral information. Yes?
How are you measuring organic content?
The organic content can be measured by specific wavelength, but it's barely seen by naked eyes. And this is only for organic content that are higher than 1.5%. Lower than that, still it's a problem. And mostly you look also on the slope was some work by a Belgian colleague that was able to map it using Apex data, recently the Apex data. But it's still a problem to measure low content of organic matter. More questions about this poster? Okay. So if you have more questions, you can catch me up after the session. We go now to cannot upload this again. Something happened. So this was the analysis of concrete. I think it's a very unique work. I mean, using spectroscopy for many things. It is very well known today. Food science, textile, paper industry, and also for civil engineering now, as we see with this process. So if you have some question for the presenter. So I will ask the presenter a question, is that possible? Did you try to measure the soil concrete spectral information against concrete strength, mostly concrete strength, like when the concrete breaks down, is it has any correlation to the spectral information you measured before? Aging, other kind of thing, because the information is there.
This time we just experimented concrete specimen with different strengths and super high strength concrete. We'd like to find out concrete building, concrete road network, and so on. So we experimented basically at this time. In the future, we'd like to perform about old concrete.
Thank you. Just want to mention that we have published a paper. It is not published yet, it was accepted, and the paper is about measuring strength of concrete using spectroscopy and then imaging spectroscopy as well. And it's a very powerful tool when you can take a cube of oblique measurement of the wall and then get immediately what is the strength of the wall in the spatial domain. And I think you are now in a very good direction, and I encourage you to continue with this. Any questions for the presenter? Okay, thank you. You can catch him afterward. Questions for Glenn, Hyperion and specular and classification vegetation?
Thanks, Lenny. When the results of your analysis were nice and clear, and pointed to the Landsat bands, I didn't catch at the beginning the process that you were using to identify the importance.
So it's random forest. So it's an ensemble of decision trees, and basically the importance measure is for a single band, if you turn that single band into random noise, say, and assess the impact that had on the classification for a particular vegetation type, that's the importance measure. So, it's one of the few techniques where you can look across all spectral bands and assess their sort of impact on the classification.
Can I extend that? Would not the bandwidth have a significant impact on that importance measure? So very narrow bandwidth versus wide bandwidth.
Yes, that's right. So I would expect. Well, I don't know how it would work in the sort of ensemble situation, ensemble decision tree situation, but I would expect that if you say through Landsat bands at that same problem, then the impact of removing or corrupting those bands would be much, much higher than the individual narrow bands. Does that cover your question?
It's really a question, a research question. I'm not
Yeah,
asking about
yeah.
an answer.
Yeah, I expect you're right.
More questions?
The report meant to be something similar to what, exactly, but something similar to what you might get from like a PLS study with architect loading, so that you would actually see the relationship of bands, the way bands, for classifying a particular parameter. Is there something?
Yeah, well, I see these as much more informative than the sort of PLS equivalent, because the PLS equivalent is characterising your data, and this is characterising the relationship between your data and the target variable. So, in a PLS sense, you have your factor loadings for individual factors, and you might have one that you know is the most important in your model, but you don't necessarily know that the regions that have high factor loadings are actually the key regions which are making it important.
I'm keen to look at Isprs.
What region do you find?
The key regions there for discriminating different forest types are sort of this blue-green region where all the forest types come up, and in the red as well. They were the sort of key ones. For a plantation, there was a bit of a peak there near infrared. Yeah, that's right. Basically, fairly broad bands in the visible regions. Yeah.
Curious to know if you were trying to see if it fits what you recommend.
Yeah, well, you could overlay any sort of broadband sensitive response function, and potentially, if you're trying to design the ideal discriminant analysis, then you possibly could use bands from different sensors if they fitted your importance functions ideally.
16 bands, and it was very nice. We have tried this with soil actually, and we found out, I was presenting this in IGC 3 weeks ago, we found out that it is possible to use these 16 bands, of course, officially to account for labor.
Vegetation is much more important.
Yeah, definitely, but vegetation will not grow without labor. Another question for them? Okay, thank you. Anomaly detection, hydrothermal operation. If somebody has question for the author, that's the case. I have a question for you. I mean, I was not. Yes, I was not actually. See anything with the thermal hyperspectral remote sensing. Do you have anything in mind? With thermal? Because you show only reflective hyperspectral remote sensing. HS. They have pairs. They have peaking bands. But it's not hyperspectral. It's multiple. Okay? But lots of spectra then, but not hyperspectral. My question is, what do you think about the future? And nowadays we have very much progress into the hyperspectral region. Would you like to live? Any questions? Okay, you can of course catch the audio afterwards. Now to the last paper. Yes.
I was wondering if you've had a chance to compare the results of using ASTA for mineral group mapping of things. I think your colleagues, yes, exactly. They did an ASTA mapping.
If you actually go to the final report, where I gave you the URL for the anomalies report, what we do in there is we actually compare the master data, the high map data, and the airborne techniques. So you can get a comparison in that report. There was some correlation, but not total correlation. Of course, the high spectral data, the high map data is much more.
I have a question. A couple.
Okay.
How long did you work on I officially close this session, but of course you are welcome to contact with the others and approach them here today and tomorrow if they are available. And I thank you everybody for attending this strange session. For me it's the first time, but I think we did well. And thank you for all others for their contribution.
Mm.